All right, day 1, part 2, question number 6. Using a right Riemann sum with 4 subintervals, what is the approximation of the integral of 1 over x from 1 to 3? So what we have to remember is that our integral is essentially the Riemann sum, right? These areas of rectangles of these particular intervals. So we notice here that each of these has a width of 0.5. So that's our delta x. So we can actually just pull that out front of the entire expression. And that our heights of each rectangle, because it's a right Riemann sum, will be based on these x values being inputted into this function, this 1 over x. So we have 1 over 1.5 plus 1 over 2 plus 1 over 2.5 plus 1 over 3. Now what we'll notice is the answers that they give us here are all in fraction form. So we're going to go ahead and convert all of our decimals to fractions. So we get 1/2, and then note here that 1.5 is the same as 3/2. So 1 over 3/2 inverts and we get 2/3 plus 1/2, and then 2.5 right here is the same as 5/2. So 1 over 5/2 is 2/5 plus 1/3. Well, notice here that our common denominator between 3, 2, and 5 is going to be 30. So our first one here will multiply by 10. We get 20/30. Our next one here, we get 15/30. Our third fraction here, we get 12/30. And this last one here is going to become 10/30. We add all these together, we get 20 plus 15, that's 35. 35 plus 12, that's 47. 47 plus 10, that is 57. Then we have 57/30. And we are rewriting this once we multiply that half, so we have 57/60. And we can see here that both of these are divisible by 3. And we can see that 3 goes into 57 19 times, so we have 19/20. All right, question 7. If y is equal to 1 plus x times f of x over root x, then what is the derivative of y? So we're going to note here that we definitely have a quotient, so we're going to have to apply the quotient rule. So the quotient rule says we go ahead and we take the derivative of the numerator. So the derivative of 1 is 0, and then the derivative of x times f of x is going to result in the product rule. So the derivative of x is 1 times f of x plus x times f prime of x. So that's our numerator. And then we multiply by the denominator. Then we subtract the numerator times the derivative of the denominator, which is 1/2, and then 1 over root x, all over the denominator squared. Now this is definitely ugly at first, but if we clean this up, we're going to see that it's not as bad as it looks. So first thing I would do is let's start by multiplying both the numerator and the denominator by rad x, and let's see if we can clean some of this up. So when I do that, this here, rad x times rad x, will just become x. So I have 1 times f of x is f of x, plus x, f prime of x, and then our rad x times rad x is x. And then I'm going to distribute that over here as well, minus 1 plus x, f of x, 1/2, and then that rad x will cancel that rad x. And that was the purpose of that. And then in the denominator, we will have this here, which is rad x squared, which is x, rad x. Now, similarly, we would like to get rid of that half that we see over here. So we're going to multiply by 2 on the denominator and the numerator, and it's going to get distributed. So we get 2 f of x plus x f prime of x minus 1 plus x f of x, and then that 2 cancels that 1/2, and then we have 2x rad x in the denominator. Now, just simplifying this and cleaning it up a bit, we get 2x f of x plus 2x squared f prime of x minus 1 minus x f of x all over 2x rad x. Now, what you'll notice here is that this 2x f of x and this minus x f of x are like terms. So together, that's just 1x f of x plus 2x squared f prime of x minus 1 all over 2x rad x. So looking closely at what we have here, we can see that that is not A. That looks like it is not C. And it is not D, so it is most definitely B. All right, question 8. If y squared is equal to 3x cubed minus x to the 4th, then dy dx, find the value of dy dx at the point 2, 2 rad 2. All right, so we have this equation here, and we want to differentiate it with respect to x. So we're going to differentiate both sides. So we're going to implicitly differentiate. So we get 2y and then dy dx following the chain rule. And then on the right-hand side, we get 9x squared minus 4x cubed. And then we want to solve this for dy dx. So we'll divide both sides by 2y. And we get that dy dx is 9x squared minus 4x cubed over 2y. And then the problem is asking us to evaluate it at this point. So we'll be finding dy dx at the point 2, 2 rad 2. So we'll plug in 2 for x in both locations. And then we'll plug in our 2 rad 2 for y. So this becomes 9 times 4, which is 36. And this becomes 4 times 8, which is 32. And then in the denominator, we have 4 rad 2. We get 36 minus 32, which is 4, over 4 rad 2, which is 1 over rad 2. And then rationalizing this, we multiply both the denominator and the numerator by rad 2. So we get rad 2 over rad 2 times rad 2, which is just 2. So our answer is A. All right, question 9. The closed interval a to b is partitioned into n equal subintervals with each a width of delta x by the numbers x sub 0, x sub 1 to x sub n, where a is equal to x sub 0 is less than x sub 1 is less than x sub n minus 1 is less than x sub n is equal to b, meaning our interval here is strictly increasing. The question is, what is the limit as n approaches infinity of the sum of 2x sub I minus 1 delta x? All right, so we know here that delta x is our width, so that's our b minus a over n. Now, we're trying to find the limit. Now, we know then that this mathematically is equivalent to the integral from a to b of 2x minus 1 dx. Therefore, finding our antiderivative, we get x squared minus x from a to b, meaning this is b squared minus b minus a squared minus a. So this becomes b squared minus b minus a squared plus a. Now, paying close attention, we notice that we can factor out b, and we get b minus 1. And actually, I don't think that's going to be the way we approach this. So I think what we're going to have to notice is that if we play with b squared and minus a squared, that those are a difference of squares. So we're going to jump over here. So I have here b squared minus a squared, just using commutative property and rewriting it, and I have minus b minus a, plus a, just rearranging. This first piece here is really just b minus a times b plus a. And this second piece over here is minus, if I pull out that negative, b minus a. I'll notice here that both parts have this b minus a. Factoring out b minus a leaves me with b plus a minus 1, which, if we look closely, we see matches option A. All right, so our last question for day 1, question 10. Let g of x be the integral of f of t from a to x, where a is less than x is less than c. The figure above shows the graph of g on a to c. Which of the following could be the graph of f on a to c? Now, note, we're trying to find, all right, so question 10. Let g of x be the integral of f of t dt from a to x, where x is between a and c. The figure above shows the graph of g on the closed interval a to c. Which of the following could be the graph of f on a to c? So we recognize here that if g of x is the integral of f of t, then g prime of x is in fact f of x. So if we wanted to get the actual graph of f of x, we would need to consider the derivative of the graph shown. So if we take the derivative, what we're going to be doing is identifying the slopes. So we notice here on a to b that the slope is positive. So we know then that from a to b, our f of x will have positive values. And then we see here that on b to c, our slopes are negative. So we expect to see negative values. All right, so question 10. Let g of x be the integral of f of t from a to x, where the interval is between a and c. The figure above shows the graph of g on the closed interval a to c. Which of the following could be the graph of a to c? So first thing we recognize is that g prime of x is in fact f of x. Meaning, in order to identify f of x, we'll be looking at the derivatives of this. Well, notice here that on the interval from a to b, we can see that the slopes are positive, and that from b to c, we can see that the slopes are negative. So we know that our graph will need to go from positive to negative values. Here we have negative to positive, so that's a no. We have positive to negative, positive to negative, positive, negative, positive, so that's a no. So then we consider the difference between b and c. Well, notice here that the slopes start out steep negative, but then become flatter towards 0. So our answer then must go towards 0 and must be b.